Hello, my dear friends. I'm Shubham from Learnohub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So, we have reached to the last chapter of your ICSE class 9th, which is chapter number 8, atmospheric pollution. Now, most of the things which we are going to study in this chapter, you would have already heard about them in your junior classes, but now we are going to see this all the concepts, okay, in little bit more detail, okay, in this chapter. Okay, so without wasting much time, let's start and let's rock. Okay, now starting with the first thing which we are going to study in this chapter is acid rain. Now, the moment you hear this word acid rain, okay, in your brain, something like this picture is forming, right? The rain which is falling on the earth, and then the earth is very much, okay, disturbed because of such type of rain. And the word acid in this term, acid rain, will threaten you that, oh my god, what that rain would be. Okay, I should never get trapped in such acid rain. Correct? But now, I know you have studied about the acid rain from your class 6th and you know the basic idea behind what is actually the acid rain. But let's now dive deeper into it. So starting from the basics first, acid rain simply means, okay, simply means the type of precipitation, just like rain or snow, okay, which is more acidic than the normal rainwater. That's simply called as that is called as acid rain. Okay, nothing super rocket science type. It's simply the rain or snow which is more acidic than the normal rainwater. Now you would say, sir, normal rainwater is acidic, okay, or neutral or alkaline. Now, when I'm saying that acid rain is more acidic than the normal rainwater, okay, so this question should come in your mind. Now, let's jump on to the answer. Normal rainwater is slightly acidic, okay, guys. Now, the pH of the normal rainwater is around 5.6. Now, you would be thinking that, oh, so the rainwater which comes, okay, or the normal rain which we see around us is slightly acidic. Like, it would be surprising for you, and you would be thinking that from now onward, I would avoid getting wet in the rainwater. Okay, I would just strictly take umbrella or raincoat and all those things and protect myself from the rainwater because now it is slightly acidic. Okay, this thing you would be thinking, but you would also be thinking in another way that people get wet in the normal rainwater, but they don't suffer from any type of discomfort, or there is no harm in, okay, playing in the rainwater and all those things. Then, sir, you are saying that it is slightly acidic. Then why it is not harming us? Because I'm telling you, this is very slightly acidic, okay, not too acidic. And now, why this slight acidicness is present in the rainwater? The reason is quite simple, okay. We have lots of carbon dioxide, okay, means in terms of oxygen and nitrogen, it is very, very less, but still, carbon dioxide is present in our atmosphere, we all have studied, and this carbon dioxide, okay, it dissolves in our rainwater, okay, which results into formation of carbonic acid. Now let's see the reaction, okay, then you would get to know. See, carbon dioxide dissolves in rainwater, simply water, okay, and it forms this carbonic acid, means H2CO3, which is a weak acid. That's the reason you don't get, we don't get any blisters or such like things, okay, or we are not harmed from the rainwater, because the acid which is present in the rainwater is carbonic acid, which is very weak acid, okay, so that is not bothering us. Fine. So this carbonic acid, okay, now we all know, I have just now said this is a weak acid. It dissociates into like this H plus and HCO3 minus, okay, that is the H plus ion, and we also say this as hydrogen carbonate ion. Fine, okay. Coming back to the point, so then you would be in a question that what is the pH range then, okay, or what in what pH range does the acid rain falls? So I have already told you acid rain is simply any form of, means simply the form of precipitation like rain or snow which is more acidic than the rainwater. Okay, so more acidic means the pH should be less than 5.6, definitely, fine. But mostly the acid rain's pH falls between 5.6 and 3.5. Okay, so pH is less than 5.6, definitely, since it is more acidic than the normal rainwater, and it is mostly greater than 3.5. But sometimes we may find acid rains having pH as low as 2. Now this type of acid rain is like quite dangerous, okay, for like organisms. Also, the acid rain whose pH is less than 5.6 and more than 3.5 is also quite dangerous, okay, quite harmful. Fine. So I hope you would have got the idea of a basic understanding of what is actually acid rain. Fine. And why now the picture in front of you is like Earth is like very much fed up because of this acid rain. Now, what is actually present in this acid rain? Now, it's not a big question, or it's not a difficult thing to understand, because just now we have seen the acid rain has the pH less than 5.6, or it is more acidic than the rainwater. And since rainwater is acidic because it has some weak acid, okay, now if acid rain is more acidic, then it has some good strong acids, okay, or it may be having some acids other than the carbonic acid. Fine. So yes, definitely acid rain has, along with the rainwater in which carbonic acid is present, it also has sulfuric acid or nitric acid. Okay, so this is the composition of acid rain. Acid rain has rainwater, carbonic acid as well, because carbon dioxide would get dissolved. Okay, so this is present in normal rainwater as well, but now this is not normal rain, this is acid rain. So the composition of normal rain is rainwater and carbonic acid. Fine, but in acid rain, the rainwater, along with rainwater and carbonic acid, there are some acids, okay, which are making the rain more acidic. And which acids? They are sulfuric acid and nitric acid. This thing would strike in your mind, then the cause of acid rain should be definitely this acids, correct? Okay, definitely the formation of these acids. Now let's focus on how these acids are formed, okay, or just the cause of acid rain. Now, how these acids, sulfuric acid or nitric acid, are formed in the atmosphere, which get mixed up with our rainwater, okay, having carbonic acid. So let's see the story first. So these acids, this nitric acid or sulfuric acid, they are formed, okay, now particularly the nitric acid is formed when the oxides of nitrogen combine with the rainwater. Wow, superb, okay. And particularly sulfuric acid is formed when the oxides of sulfur, okay, oxides of sulfur combine with the rainwater. Okay, now let's see one by one how these oxides of nitrogen combine with rainwater, and first of all, from where these oxides of nitrogen are coming or the oxides of sulfur are coming, which are then in turn reacting with the rainwater and producing these acids, man. Okay, so the first thing is we are going to see from where these oxides of nitrogen are coming. Okay, so oxides of nitrogen, like from when we say in terms of natural formation or in nature, okay, the nitric oxide, this NO or nitrogen monoxide, we can say, okay, this oxide of nitrogen is formed naturally, okay, when thunder and lightning is there. So nitrogen and oxygen combines and forms nitric oxide, okay, or nitrogen monoxide. But now this nitric oxide, apart from this nitric oxide also, the nitric oxides, okay, which are getting formed artificially is because of the burning of fossil fuels in the automobile engines. Now you would say, okay, so elaborate like slightly in more detail how burning of fossil fuel in automobile engine is generating this nitric oxide. Okay, so see what happens when the automobile engines are working. So they burn fossil fuels, we all know, petrol and all those things. Okay, and when this petrol is burnt, sufficient amount of heat or the temperature is okay, reaches to a sufficient amount, okay, sufficient high amount or sufficiently high temperature is reached, at which the nitrogen in the atmosphere and the oxygen in the atmosphere talks with each other and says that let's combine, man. Okay, now the temperatures are favorable for us to combine, okay, because temperatures are too high. So at this high temperatures, okay, both these gases which are very much abundant in the atmosphere, we all know, they shake hands and they say that let's react, and they react and form nitric oxide or nitrogen monoxide. Fine. Now this nitric oxide or nitrogen monoxide, now you have to balance these reactions on your own. They are quite easy, correct? 2 nitrogen, 2 oxygen, which means 2 nitric oxide. Simple. Fine. So in this way, you need to balance. And now the story goes ahead. So this nitric oxide doesn't stop here. Okay, what it does, it gets converted into nitrogen dioxide. Okay, now it adds up one more oxygen. So this nitric oxide, since it wants to add one more oxygen, it needs to again react with oxygen. So nitric oxide reacts with oxygen and it forms nitrogen dioxide. This reaction also you can balance on your own. So ultimately nitrogen dioxide is formed by further oxidation of nitric oxide. Now this nitrogen dioxide, this is the main culprit, man. This nitrogen dioxide reacts with the rainwater and it forms, okay, nitrous acids and nitric acids. Okay, so let's see. This nitrogen dioxide reacts with rainwater and forms nitrous acid, HNO2 and nitric acid. So from here, in this way, nitric acid is formed. And this nitric acid which is formed, fine, in the atmosphere, when the rain comes, it dissolves in the rainwater and turns this normal rain into acid rain. Clear? So in this way, nitric acid, okay, is causing the acid rain, or the formation of nitric acid from the oxides of nitrogen is causing the acid rain. Now in the similar manner, okay, we can see here how just now we have seen how the oxides of nitrogen, okay, is resulting into nitric acid, which is in turn mixing with the rainwater and resulting into the formation of acid rain. Fine. So in the same way, how oxides of sulfur are then doing this thing. So oxides of sulfur, first of all, let's see how they are formed. So we all know, means the coal, okay, it has some sulfur in it. Okay, apart from carbon, which is like majority, which is like present in major amount in coal, sulfur is also present. And this sulfur, okay, when we burn the coal, this sulfur also reacts with the oxygen in the atmosphere and it gets converted into sulfur dioxide. This oxide of sulfur. Fine. Okay, so how? By burning of coal or by burning of petroleum products as well, okay, we get sulfur dioxide. Clear? Now here again, yeah, petroleum products, definitely it means gasoline, means like petrol and all those things which we get from petroleum. Okay, so this obviously means that when we are driving the vehicles or when we are using the petrol in our cars and two-wheelers and all those things, okay, they are also resulting into the formation of sulfur dioxide, just like how our automobile engines are responsible for the production of nitric oxide. Okay, they are not directly producing nitric, means how they are, not leave about the directness, but how they are producing the nitric oxide, they are generating sufficient temperature so that the nitrogen and oxygen are reacting. Fine. So here sulfur dioxide is being produced by the petroleum products combustion, and this sulfur dioxide, then it doesn't stop there. Okay, it also gets oxidized to sulfur trioxide. Okay, so how? The sulfur dioxide will react with oxygen, it will form sulfur trioxide. But yes, here sulfur dioxide as well as sulfur trioxide, they both react with the rainwater. Now these oxides of sulfur, okay, both react with the rainwater and they form sulfuric acid. Okay, now this sulfuric acid in turn, which is formed in the atmosphere, it gets mixed with the rainwater, resulting into acid rain. Correct? Now let's see the reactions, how sulfur dioxide and sulfur trioxide combines with the rainwater and forms sulfuric acid. So see, sulfur dioxide, simply it combines with the rainwater, that is water, but along with oxygen as well. Okay, it needs oxygen also, and then it gets converted into sulfuric acid. Okay, so sulfur dioxide, it combines with water, but also it needs oxygen. Okay, so sulfur dioxide, oxygen, water, giving sulfuric acid. Similarly, sulfur trioxide, SO3, it simply needs just the rainwater and it forms sulfuric acid. That's it. Okay, sulfur trioxide, water, it forms sulfuric acid. Clear? Clear with the equations as well, because these are needed. Okay, you should know these equations, you should know the chemical reactions, how the oxides of sulfur are getting formed and how these oxides of sulfur are reacting with the rainwater and forming these acids. Similarly, how the oxides of nitrogen are getting formed and how these oxides of nitrogen, that is nitrogen dioxide, reacting with the water and it is forming nitric acid. Okay, and both these nitric acids and sulfuric acids, when they are mixing with when they get mixed with the rainwater, it results into acid rain. Now, enough about the acid rain, right? Now you would be eager to know, sir, what actually is happening because of the acid rain, okay, on our earth. So the impacts are quite okay, disturbing or dangerous as well, because see, this acid rain, which is like quite acidic, when it falls on the soil, it is making our soil acidic. Okay, so it is changing the nature of the soil. Okay, so we all know crops need a particular type of soil to grow, okay, very nicely. But if the nature of the soil is being changed, okay, there would definitely be some challenges for growing the crops in such acidic soils. Clear? So this is the first thing. Another thing is it is also affecting our water bodies. So when this acid rain is falling on the oceans or seas or lakes or rivers, what it is doing is it is making these rivers and lakes acidic. Correct? So what is happening because of this acidic nature of the rivers and the lakes? These water bodies are not suitable for the aquatic life to live peacefully. Okay, so aquatic life is having some threat, okay, because of such acidic water. Clear? So apart from this, we all know, we are studying from the, means like we have heard from somewhere or the other that our Taj Mahal is definitely, means like getting affected because of this acid rain. Why? Because see, it is such a beautiful monument, and here acid rain is affecting our Taj Mahal. It is making the it is changing the color of our Taj Mahal. Okay, so such monuments are also getting degraded because of the acid rain. Apart from this, acidic conditions, okay, they increase the rust formation. So the metals are getting more and more corroded. Okay, so corrosion is increasing because of the acid rain. Since because this acid rain, okay, when it falls on the iron particles, okay, or iron gates or iron, so not iron particles but iron gates or iron articles, I want to say. So on such iron articles, we all know they are exposed to air and moisture, so oxygen and moisture, okay, or oxygen and water vapor or water, so they rust. But along with the oxygen and water, if acid is also present, then the rusting increases. So same happens here, okay, because of the acid rain. So we know acid rain has water, it has some acid, also the oxygen is there in the atmosphere, so or water also has dissolved oxygen in it. Okay, so all the things are getting to the iron, so along with the oxygen and water as well, it is getting some acids which is increasing the formation of rust. Okay, so acid rain increases the corrosion of metals. So already we are like very much worried and very much in loss because of the rusting and corrosion of metals, and acid rain is again making the things more and more worse for us. Fine. And the last thing is how to prevent this acid rain. भाई कैसे रोके, okay, acid rain को? So the prevention is simply we need to cut the root cause. So from where the acid rain, okay, or which is the starting point from where the acid rain, okay, is getting formed. The starting point is simply the oxides of nitrogen and sulfur. Correct? Now see, the carbon dioxide is getting mixed with water, but carbonic acid is a weak acid, so it is not affecting the pH of the rainwater, it is not making water too acidic. But this sulfuric acid and nitric acid, man, they are causing a problem for us. Correct? And these are formed because of the oxides of nitrogen and sulfur. So we need to cut the root cause itself. We need to stop this oxides of nitrogen and oxides of sulfur from getting into the atmosphere. Okay, so if we could control their emissions, we can control the formation of, or we can limit the formation of this sulfuric and nitric acid. And once this sulfuric and nitric acid formation, or once the sulfuric and nitric acid are less and less formed in our atmosphere, they would get less and less mixed with the water and resulting into less and less acid rain. Correct? So how we can do this? For cutting the emission of oxides of nitrogen and sulfur, we need to keep a control over those activities which are giving up the oxides of nitrogen and sulfur. That is simply, we know oxides of nitrogen are being generated because of the burning of fossil fuels in the automobile engines. Okay, oxides of sulfur, that is sulfur dioxide, is being produced due to the combustion of petroleum products. So if we could use the petroleum products or the fossil fuels which are having less sulfur content, correct, that would bring less sulfur dioxide into the atmosphere. So the petroleum products or the coal which is getting burnt, which is having more sulfur content, it is resulting into more sulfur dioxide. Okay, emission of more sulfur dioxide into the atmosphere. But if you take this coal and this petroleum products having less sulfur content, so less amount of sulfur dioxide would be formed. First thing, correct. So using fossil fuels having low sulfur content. Second thing is, the automobile engines are responsible because they are generating such higher temperatures at which the nitrogen and oxygen are combining to form nitric oxide, which is in turn blah 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 getting converted into nitrogen dioxide, and then again we all know it is getting converted into nitric acid by reacting with water. So if we would cut the formation of this nitric oxide by switching to the electric vehicles, then okay, the automobile engines, they are burning this fossil fuels. So if we would stop the burning of fossil fuels in the automobile engines and we would switch to the more green technology or green method, which is using the electric vehicles, okay, we could stop the emission of nitric oxide. Fine. Because nitric oxide formation is just because of the higher temperatures developed by the combustion of fossil fuels in the automobile engines. So by replacing the automobile engines, fine, by the electric vehicles, okay, or the batteries, we can stop the emission of nitric oxide as well. And the last one is, we can use scrubber, okay, to reduce the emissions, okay, or to control the emissions of these oxides, because this scrubber is a device which is which absorbs gaseous pollutants. Okay, device which absorbs gaseous pollutants. Clear? Tan-ta-dan. So now let's move on to the second topic of this chapter. The second concept which we are going to study is about the global warming. Now this also thing you have already heard about, okay, in your previous classes, but let's now deep dive into how this global warming, or how, okay, means the greenhouse effect, okay, is actually taking place. Fine. Now we all know this global warming, okay, we will see one by one how it is formed, but for that first let's try to understand what is greenhouse effect. Fine. Now the name itself is very interesting and the concept of the greenhouse effect is also quite interesting, but now you have to pay attention pay more attention to this thing, because see, the radiations, okay, from the sun, we are going to start from there itself. So we all know sun is giving us like lots of energy, okay, and now this energy is being carried to us in the form of radiations. Fine. Now these radiations, okay, out of this, most of the energy which the sun is giving to us is coming in the form of the radiations, okay, which we call as visible light. Okay, the radiations in the visible region. So I'm just writing here, visible light. So most of the energy from the sun is from this visible light. Okay. Now some amount of radiations, okay, which are coming from the sun to the earth, okay, as a form of energy, are the ultraviolet radiations. Now we all have heard about this. Now you would be knowing these are very harmful, sir, and this don't even reach to the surface of the earth. We have already studied, because there is a protector of the earth known as ozone, and this ozone is not allowing the ultraviolet rays to enter through the atmosphere, okay, or this ozone is not allowing the ultraviolet rays to reach the surface of the earth. Okay, fine. So very little amount of radiations, okay, or very little amount of energy from the sun is in the form of ultraviolet radiation. Okay, very little, and out of that very little also, most of it, okay, most of it is being absorbed by the ozone. Clear? So this is the ozone, suppose, like this. Now here these are getting absorbed, so we are like not getting harmed by the ultraviolet rays. The more about it we are going to see in the next topic, which is actually the ozone depletion. Fine, but let's stop here. Now, apart from this, some amount of radiation is also in the form of infrared radiation. Okay, IR radiation we can see. Okay, but see, both this type of radiations, ultraviolet radiations and infrared radiations, are very quite small. Out of this also, ultraviolet radiations, most of it is getting absorbed. Okay, but now let's focus on the visible radiations, which are the most of the radiations, or the most of the energy from the sun is coming in the form of this visible light. So what is happening? The visible light which is coming from the sun, okay, it is being passed through the atmosphere very nicely, and it reaches the earth's surface. Okay, it reaches the earth. So out of this, most of the visible light radiations which are reaching the earth, okay, most of them means like partly, okay, not most of them, out of this, most of the visible light, okay, or out of this visible light which is coming from the sun in the form of energy, okay, on the earth, half of it or partly is absorbed by the earth. Okay, I will show it with different color. So partly is absorbed by the earth and partly is given back into the atmosphere. Means given back, okay, or radiated by the earth. Okay, so partly it is absorbed, partly radiated. But this radiated visible light, okay, it just passes through the atmosphere, okay, without any interruption and goes again into the space. Okay, but the amount of visible light which is being absorbed by the earth, what is happening because of that? Our earth is getting heated. Okay, so very nice. Okay, very nice till this point. Our earth is getting heated, but heated things radiate the heat energy in the form of IR radiations, infrared radiations. So same way, our earth also, since it is becoming now hot, okay, because of this visible light radiations which it is absorbing, so it gets hot, and because of this, since it gets hot, it gives off the infrared radiations. Okay, I will show it with different color. Okay, I'm with black, like this, infrared radiations. Now this is the thing which we need to focus on. Now see, visible radiations are getting passed through easily, but this infrared radiations, okay, which are being radiated by the earth, since it is now heated up, okay, some of these infrared radiations pass like this, directly pass, okay, but some of them get trapped like this. They get trapped in the atmosphere. Now, because of this trapped radiations, okay, our earth surface as well as the lower atmosphere gets heated up, and this thing is called as greenhouse effect, the trapping of some of the infrared radiations radiated by the earth. Okay, this is called the greenhouse effect. Now, this greenhouse effect is of a great significance to the life, okay, on the earth, because if some of the infrared radiations wouldn't have been trapped, okay, let's see it later on who are trapping them, but if they wouldn't have been trapped, some of the infrared radiations radiated by the earth, then our earth would be not a suitable place for the life to exist. It would have been cold and barren like moon. Okay, so it is necessary for the existence of life. What? Greenhouse effect. Okay, now this greenhouse effect, it occurs naturally. Fine, because now here in the atmosphere we have just now seen some of the infrared radiations are getting trapped, some of them are getting passed. Okay, so now why these are getting trapped? Let's get on to this thing now. So these are getting trapped because of some gases like carbon dioxide and water vapor, okay, which are like naturally present in the atmosphere. Okay, carbon dioxide and water vapor. So these two gases, they don't allow some of the IR radiations to pass through, okay, and keep them inside, okay, reflect them back inside, okay, so that they heat up the earth and make the earth a suitable place for life to exist. But apart from these two gases, okay, there are some another gases which are being artificially produced by humans, okay, like okay, now apart from these two, there is also one more gas, ozone, which is also acting as a greenhouse gas, which is also acting as a gas which traps the infrared radiation for now. Okay, now apart from them, okay, like another gases which humans are producing, like methane. Okay, now see, carbon dioxide can also be produced by humans, but it is also occurring naturally as well. Okay, apart from the naturally occurring gases, okay, which are trapping the infrared radiation, some of them are being artificially produced by us, which is like methane or chlorofluorocarbons, okay, this CFCs, fine, or the oxides of nitrogen, which is this nitrous oxide. And now, yeah, let me tell you an interesting thing about this nitrous oxide. This is also called as a laughing gas. Ha 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 ha. Okay, yeah, I'm not joking. It is seriously called as a laughing gas. Okay, and it makes people laugh as well. Okay, you can just search it later on. So these are the gases which are trapping this infrared radiation, and since they are trapping this infrared radiation, these are called as greenhouse gases. Okay, since they are trapping the infrared radiation, what they are doing, they are responsible for this greenhouse effect, and since they are responsible for the greenhouse effect, they are called as greenhouse gases. So from now onwards, I'm not going to read greenhouse gases entire word, I'm just going to call them as GHG. Okay, greenhouse gases. Fine. Now you would be thinking that why this greenhouse term? Okay, why the effect is called greenhouse? So this greenhouse word is been derived from actually greenhouse. Okay, yeah, there are actually greenhouses, okay, which humans build. And now why they build and how are these greenhouses? These greenhouses which are so called as greenhouses, these are the houses made up of pure means these are houses made up of glass. The walls are made up of glass, the roofs are made up of glass, like this. Okay, and these are built in such places where there is cold conditions, where the climatic conditions are quite cold. And why they are now built, you would be thinking. So they are built because some plants need, okay, some warm conditions. So what this greenhouse does what this greenhouse does, okay, what's its role? Now you would try to correlate this thing. Okay, you try to correlate this thing. This greenhouse, it also allows the sunlight to enter into it, okay, to reach the plants which have been grown inside the greenhouse. Fine, but we all know here the sunlight, okay, it is reaching the earth's surface as well. Fine, and here it is heating the earth's surface. So after getting heated up, what earth would do? It would radiate back the heat in the form of infrared radiations. So these infrared radiations then try to move out of this glass. And in the same way, just like our greenhouse gases are trapping the infrared radiations, okay, this greenhouse made up of glass is also trapping the infrared radiations inside, okay, keeping the greenhouse like quite, okay, at a temperature which is higher than the temperature outside, okay, outside the greenhouse, means keeping the conditions warm, in short, okay, by trapping the heat inside the greenhouse. Now this heat is necessary for the plants to grow, so that's the reason we build such glass houses and we call them greenhouse. Okay, but since they also work same as like this carbon dioxide or methane or water vapor gases, okay, or the effect shown by this greenhouse, okay, is also similar to that of just now we have seen in the case of earth. That's why we are terming this effect as greenhouse effect. Clear? And these greenhouse gases, which we have already noted down, so these greenhouse gases are contributing to the greenhouse effect, but at different levels. Okay, some of the greenhouse gases like contribute too high for the greenhouse effect, which means that they are like very much fond of trapping the infrared radiations. Fine, and which are those? See, the first one is carbon dioxide. 50% contribution towards the greenhouse effect. Means like half the greenhouse effect is just because of carbon dioxide. So now if you would think that carbon dioxide is bad and we don't want carbon dioxide at all in our atmosphere, then you are taking a risk of such a thing, okay, or then you are taking a risk which would extinguish, okay, or which would like erase the existence of all life on the earth. Okay, because if you would remove carbon dioxide, which is responsible for the 50% greenhouse effect, then only 50% greenhouse effect would be intact. And yes, our earth definitely wants this natural greenhouse effect to maintain the temperature of the earth such that the life exists on the earth. Okay, so carbon dioxide is, yes, you would be thinking till now this point that maybe you would be thinking that carbon dioxide is a bad gas and we don't want carbon dioxide, but yes, carbon dioxide is also very much necessary. Okay, also you all know the uses of carbon dioxide. We have studied in class 6 itself that it is used for photosynthesis by plants and all those things. But apart from that also, carbon dioxide plays a very important role in greenhouse effect in maintaining the earth's temperature. Okay, apart from carbon dioxide, methane contributes 19%, chlorofluorocarbons, okay, these are known as freons, okay, they contribute 17%, ozone contributes 8%, nitrous oxide, that is laughing gas, haha, contributes 4%, and lastly is the water vapor, which is contributing 2%, only 2%, but yes, still it is contributing, fine. Okay, now let's move ahead to see the sources of these greenhouse gases. Okay, so first of all, the very much important greenhouse gas for us is carbon dioxide. And what are the sources of carbon dioxide? Like we already know the sources, right? They are quite used to us, means like we are like giving itself, we ourselves are giving up this carbon dioxide, correct? Because we are respiring, correct? And like us, animals and plants, they are also respiring, so they are also giving up carbon dioxide. So one of the source of carbon dioxide is respiration. Another is industrial processes like manufacture of lime also gives up carbon dioxide. Apart from that, if you would think, okay, carbon dioxide is also being liberated because of the burning of coal, petrol. Now you would be, it is an interesting fact to know that, see, if you all now, maybe some of you may be having some of your parents may be having vehicles which definitely you would be using, not EVs but the vehicles based on petrol, okay, running on petrol. Now very interesting thing to know that 1 liter of petrol, okay, when you use it, this 1 liter of petrol is not even 1 kg of petrol, okay, it is like roughly around 700 grams of petrol. But this 700 grams of petrol creates about 2.3 kgs of carbon dioxide. So superb, see, means like 2300 grams of carbon dioxide. So 700 grams are producing 2300 grams, which means 3 times of its own weight the petrol is producing the carbon dioxide. So this carbon dioxide which we are giving up, this would be a reason, okay, a major reason to worry. Okay, but let's see ahead why I'm talking like this now. But first of all, let's focus on the sources of these greenhouse gases. So burning of coal and petrol, and the industrial processes like manufacturing of lime, I have already told, and the respiration. Okay, apart from that, the another greenhouse gas is methane, the water vapor. And here water vapor is the major source of water vapor. Like we all know, water evaporates from the sea, oceans, lakes, rivers and all those things, and from what not. Okay, but apart from that, when we are talking about the chemical industries, okay, so the major sources, or we are talking about some chemicals which give us the water vapor on large scale, which is hydrocarbons. Okay, when we burn the hydrocarbons, we get water vapor. How? Let's take an example. See, so methane is an hydrocarbon. Okay, now when we burn methane, okay, in oxygen, absolutely, I'm talking about burning the methane in oxygen. So we get carbon dioxide and water vapor. Okay, carbon dioxide and water vapor. So here water vapor is being released into the atmosphere. So more and more burning of methane would result into more and more release of water vapor. And we have seen, though it is contributing 2% only for the greenhouse effect, but still it is contributing. So increasing the amount of water vapor would result into increased greenhouse effect, correct? Let's see it later. Then Next is oxides of nitrogen. So many chemical industries give up this oxides of nitrogen into the air. Apart from that, methane. Now this methane, it's quite interesting to know. Okay, we can use this methane gas in order to cook the food. Okay, how? By making the organic matter decompose in the absence of oxygen. How you can do this? Maybe you would have studied in biogas plants. Okay, you need to put the organic matter in a tank, and then you should ensure that the tank is closed such that, okay, or the tank is not in contact, or the organic matter is not in contact with the oxygen. Okay, so what happens that the decomposition of the organic matter takes place, but in the absence of oxygen. And this decomposition of organic matter in the absence of oxygen, okay, it results into the formation of methane gas. Okay, so see, anaerobic decomposition, which means decomposition in the absence of oxygen. Anaerobic means absence of oxygen. So decomposition in the absence of oxygen, of whom? Of organic matter. Okay, so in soil, water, it results into methane gas. Apart from that, okay, so here also large quantities of methane gas gets produced because of this first anaerobic decomposition thing. Another important thing is incomplete combustion of the fossil fuels. So when we burn the fossil fuels, if they are not completely burnt, they may give methane. Okay, incomplete combustion means we are not completely burning the fossil fuels. Okay, fine. And also here the anaerobic decomposition, so this takes in soil, so we can carry out this in soil or not by ourselves. Okay, if this gets carried out naturally in the soil or water, then also methane gas is getting evolved. Fine. So now like it's enough about the greenhouse effect and greenhouse gases and their sources and all those things. Now let's come back to the main point, that is global warming. Okay, now why I have told you this long story of greenhouse effect is because global warming is simple, a very simple thing. This means that it simply means rise in the average temperature of the Earth's surface. Okay, so this is our Earth, and if there is a rise in the average temperature of the Earth's surface, which means that if our Earth is getting hotter and hotter, this simply means it's global warming. Okay, global warming is taking place. Okay, so simply the rise, okay, in the average temperature of the Earth's surface, clear, is global warming, increase in the average temperature of the Earth's surface. Now, why is this taking place? Now, we all know greenhouse effect is in effect naturally. Fine. But if this greenhouse effect increases, okay, to such an extent that it is heating our Earth too much, our Earth doesn't want this much heat, or our Earth doesn't want, okay, the temperature on the Earth is like quite okay for the survival, but now the greenhouse effect is increasing such that it is trapping more and more infrared radiations, resulting into heating of the Earth's surface, which would in turn result into increase in the average temperature of the Earth's surface, which is global warming. Correct? So now you would say, sir, increased greenhouse effect is resulting into global warming. Yes. Now why the greenhouse effect would increase? Simply because of the increase in the amount of greenhouse gases. Because what is actually, we have studied greenhouse effect, it is just simply the trapping of the infrared radiations given by the Earth, okay, when it gets heated up because of absorption of the visible light from the sun. Okay, but this absorption of infrared radiation given by the Earth is taken, who is absorbing them? The greenhouse gases. So if their amount would increase, okay, more and more amount of greenhouse gases would be present here, then they would increase, then they would absorb more and more amount of infrared radiations, which would result into the increase in the Earth's average temperature, okay, or increase in the average temperature of the Earth's surface, okay, which is simply global warming. Clear? Now here let's have a look that, see, suppose now you would be saying, sir, okay, fine, the global warming is because of the increased greenhouse effect. Okay, but what it would do? Okay, what would be the consequences? See, the rise in the temperature of the Earth's surface, okay, by even small amounts can lead to bigger consequences. Fine. And now which are those consequences? Let's have a look over it. The impacts or the effects of global warming. The first one is increase in the sea level or rise in the sea level. Now what would happen because of the rise in the sea level? The coastal areas of the countries like ours, India or Bangladesh or Netherlands or Maldives, okay, such countries, coastal areas are having threat of getting submerged because of increase in the sea level. Okay, and this would happen because of increase in the temperature of average temperature of Earth's surface, that is global warming. Fine. Now, one interesting question for you. So why it would happen? Simply because of the why the sea level would rise. See, the Earth's temperature would increase, then the ice on the Earth, okay, that is in the form of glaciers or in the form of the polar ice caps, okay, on the North Pole, on the poles, okay, the ice caps are there, okay, or the ice is there. So on the poles the ice is there because of the melting of that ice, okay, or because of the melting of the glaciers. Now why they would melt? Because the temperature of the Earth is increasing, so this would result into melting of the ice, correct? So ice, when it gets melted, okay, it would result into water. Now my question is, there is ice, okay, present in large amounts at the North Pole and the South Pole. Hear it carefully, okay, because this is not, you would need to think a bit, or you would also need to have some information or slight knowledge about geography as well. Okay, so my question is, we are having ice on the North as well as South Pole. This is the North Pole, okay, Arctic, okay, ocean is there, and this North Pole we are having this ice, and here in the South Pole we are having an entire continent named as Antarctica, okay, which is also having ice. So because of melting of the ice of Antarctica, or because of the melting of North Pole or the ice at the North Pole, okay, like my question is, because of melting of ice on both the poles, the sea level would increase, or just because of melting of ice on one of the poles? Okay, so you can pause the video here and you try to think, okay, thinking logically. Fine. So I hope you would have tried. Let me tell you the answer. So see, on the North Pole we are having the ice, but here the ice is not over any land. Fine, they are simply huge slabs of ice, okay, or huge ice, okay, huge quantities of ice which are like floating in the ocean. So this North Pole ice is like this. Now we all know, if you take a glass of water, okay, which is like almost full, and then I'm asking you a question, you're putting, okay, a ice cube, so the water is now like on its rim, okay, on its just on its rim, okay, this much. Now what do you expect? After melting of this ice cube, would the water overflow, or the water won't overflow? What would be your answer? Okay, I hope you would have given some answer, okay, by pausing the video. But let me tell you, okay, the water won't overflow. Now why? We have to apply the concepts, we have to apply the logic which we have studied in the science, okay, though we have studied it in class 6th or class 7th or class 8. We have already studied this thing, okay, or we can relate this thing to the anomalous expansion of water. We all know that when we are crossing the 4 degree Celsius, okay, barrier, okay, so this is 4 degree, okay, this is 0 degree, we are going into the -1, -2 degree Celsius temperature, and from here 5, 6, 7, okay, we all know when we decrease the temperature till 4 degrees centigrade, okay, what is happening? The water gets contracted, okay, so it becomes more and more denser, and after 4 degrees Celsius, okay, on further cooling, we know water expands. That is called anomalous expansion of water, and that expansion leads to, that expansion, okay, of water goes on, continues, okay, below 4 degrees Celsius. So we all know after 0, the water would be in the form of ice. Fine, and this ice which is present in the North Pole is also like beyond 0 degrees Celsius temperature itself, correct? So most of the ice which would get melted, okay, what would happen? The temperature would increase, but we know now from going from this point to this point, we know the density is increasing. The density is decreasing. Okay, and we know density and volume has inverse relationship. So volume is increasing. Okay, when we are moving from 4 degree to like colder temperatures, but when the ice is melting, it would move from the colder to hotter temperatures. So it would exactly have the opposite effect of this. So density would increase, volume would decrease. Correct? So when ice would melt, the water molecules would occupy less and less volume, since volume is decreasing. So since they would occupy less and less volume, initially in the form of ice, whatever volume they were occupying, okay, that would be more. Now when they are converted into water, they would occupy less volume. Superb. Correct? Correct. So that's the reason, since they would occupy less volume, okay, not more volume, so water won't overflow. In the same manner, the North Pole ice would melt, but after, when it gets converted into the liquid water, okay, the sea level won't rise because of the North Pole ice. Okay, the sea level would definitely rise now because of the ice present on the Antarctica, because this ice is present on the land. Fine. So when this ice would melt, all the water would flow through this Antarctica or the land of the Antarctica and would enter the sea. Correct? And when this water would enter the sea, we all know it would increase the sea level, thus threatening the coastal areas of the countries like India, Bangladesh, or Netherlands or Maldives. Okay, because these coastal areas may get submerged. Clear? Apart from this, because of the increase in the temperature of the Earth's surface, okay, there would be high energy, and because of this high energy, there would be extreme weather conditions. So at some places, okay, because of the global warming, there would be huge amount of rain. There would be storms and huge amount of rain resulting into floods. And at some places, there won't be even a single drop of rain. Okay, it would turn the conditions as the drought conditions, like the drought conditions. So this extreme weather conditions would definitely impact the human life as well as the ecology, as well as the entire organisms which are present on the earth. Okay, after that, okay, the ocean water or the sea water, since carbon dioxide is increasing. Now see, greenhouse effect is increased greenhouse effect is resulting into global warming, right? Increased greenhouse effect is because of the increase in the greenhouse gases, increase in the amount of greenhouse gases. So carbon dioxide, if we would increase the amount of carbon dioxide, okay, that would result into increased greenhouse effect, that would result into global warming. So because of this increased carbon dioxide, okay, global warming is taking place. But now you would think that this increased carbon dioxide present in the atmosphere can also get dissolved in the ocean water, right? So now you would think, sir, then there is a way of reducing the carbon dioxide, okay, from the atmosphere. How? Since there is one way in which carbon dioxide can be reduced from the atmosphere, that is by getting dissolved into the oceans. And we have lots and lots of oceans on the earth, like we have lots of water on the earth. So lots of carbon dioxide can get dissolved, but there is a problem here. There is a catch here. Lots of carbon dioxide, if it gets dissolved, okay, because of the high amount of carbon dioxide, okay, or high concentration of carbon dioxide in the atmosphere, it would turn our oceans acidic. Correct? Because it would make carbonic acid. Now, though it is a weak acid, but still it is an acid. So it would turn our water acidic. And because of this acidic water, also along with its high temperature, because Earth's surface temperature is increasing, so the ocean water's temperature would also increase. So this warm and acidic water would possess a threat to the aquatic life. Okay, for example, the corals, which you know, they would not be okay with this warm and acidic water. Okay, so the coral reefs, the beautiful coral reefs which we have, okay, which we can see near Australia, okay, the Great Barrier Reef and all those things, won't sustain too long, okay, or they have threat from such type of acidic and warm water. Clear? Now, another effect of global warming is simply, we all know, the earth has now heated up because of global warming, and because of this heat, the oceans would also get hotter, correct? Now, we all know that when the temperature is or when we increase the temperature, the water evaporates faster. Correct. If you want to evaporate the water from the solution of salt and water, so if we would keep it in the room temperature, it would evaporate very slowly. But if you would heat it, it would evaporate quickly. The water would evaporate quickly. Correct. So here also the ocean water is also heated up. So now the evaporation of water would be quicker. So more amount of water vapors would get generated. Correct. Or we can say the generation of water vapor, okay, would be faster. So here water vapors would be more and more, okay, as compared to the normal conditions. And now more and more water vapors in the atmosphere, what they would do, we all know water vapor itself is a greenhouse gas. So it would more and so if more and more water vapors are increasing, or if the amount of water vapor is increasing, correct, what would happen? It would increase the greenhouse effect. In turn, again, it would increase the global warming. So more global warming would occur. Fine. So very logical thing, very simple thing. Now moving ahead, here the another effect is change in the rain pattern. Okay, so in the pattern in which we observe rain is occurring, okay, so that would change, and this change would induce two very bad things. What is first one? It would shift the crop zones. Okay, now what is the meaning of this? Let me give an example. See, here in the Russia, okay, and here in the Canada, okay, so the wheat producing zones are there. Fine. But because of such global warming, the wheat producing zones in the Russia and Canada would shift upwards, okay, to these polar regions. And these polar regions are not that much fertile. Okay, so this would impact on the production of wheat in these nations as well as in these regions, okay, which may have far more consequences, because now if the production would be reduced, we all know what we would eat then. Okay, that's the simple logic. If the food production reduces, then what we would eat. Fine. Another very bad consequence or very bad impact of the change in the rain pattern is the wildlife gets disturbed, okay, and wildlife species may get extinct as well, because you know the rain pattern, if it shifts from one area to the another area, or if the rain pattern changes of that particular area, then we may not see that much forest or vegetation in that area. Okay, and we all know a particular area's forest and vegetation is the habitat for the wildlife species. Okay, so if the forest and vegetation won't exist in that particular area because of the change in the rain pattern, so if no forest or vegetation, then the wildlife species in that region would be deprived of their habitat and they may die. Correct? So that's not a good, actually a good thing which would happen. Correct? So these are the effects. Now let's see how we can reduce this global warming. Fine. Very simple steps we have to take. First of all, we all know global warming is caused because of the increased amount of greenhouse gases. Correct? So we should cut the root itself. How we can reduce the greenhouse gases amount, okay, or how we can reduce the amount of greenhouse gases in the atmosphere. How? By just not letting more and more greenhouse gases to enter the atmosphere. Now we all know carbon dioxide is such a greenhouse gas which is contributing for like 50% of the greenhouse effect. Okay, so if we would control carbon dioxide itself, then we would control a greenhouse effect to a larger extent. Now, if we want to reduce the emissions of carbon dioxide in the atmosphere, what we need to do is we need to minimize the activities which are releasing the carbon dioxide, which are like burning fossil fuels like coal and crude oil. Okay, means like use of this fossil fuels like coal and crude oil should be reduced. Now how let's see. Coal like burns and gives carbon dioxide, we all know, and crude oil, from crude oil we make petrol, and this petrol, I have already told you, petrol, 1 liter of petrol burns and gives like 2.3 kgs of carbon dioxide. Okay, so if we would minimize their uses, for example, if we would not use petrol, okay, to large extent, then the need of crude oil would be minimized. Correct? Also, if we would not use coal to a larger extent, then the need of coal would be minimized. But both of this thing, okay, less usage of petrol, less usage of coal would reduce the emission of carbon dioxide. That's why I have written minimize the use of fossil fuels like coal, because if we would use minimum coal, minimum carbon dioxide would get emitted. If we would use minimum crude oil to convert it into or minimum crude oil to make petrol. Okay, so this means that we would use less petrol, so less carbon dioxide would get emitted in the atmosphere. Okay, so in this way we have to minimize those fossil fuels. In short, what I mean is we have to minimize the usage of those fossil fuels, okay, which gives off carbon dioxide, okay, or greenhouse gases. Clear? Another thing is how at basic level, at your level, at my level, how we can do this. I actually have given this example a lot of times. We can use electric vehicles. Fine. I'm not a promoter of electric vehicles, but here the solution, here the scenario is such that the solution which we can adapt is usage of the battery operated vehicles, because they won't release carbon dioxide, because we won't use petrol, right? So carbon dioxide emission would reduce. Fine. Clear? So next thing is, now if we want to reduce the amount of carbon dioxide in the atmosphere which is leading to the increased greenhouse effect, we need to plant more trees, correct? Because trees absorb that carbon dioxide and it converts it into glucose, photosynthesis, correct? So if we would plant more and more trees, more and more carbon dioxide would get consumed. So the amount of carbon dioxide in the atmosphere can be controlled, thereby controlling the greenhouse effect and reducing the global warming. Fine. Another thing which we can do is, like, we can avoid burning wood by cutting the trees. Now, how is it now? And okay, if at all we want to burn the wood, or if at all we want, okay, something with if at all we want to do something with the wood, okay, and now it's like mandatory for us to cut the tree. So what you should do is, suppose for like example, we need wood to burn. For that we are cutting a tree. So mandatorily what you can do is, in order to avoid global warming, or in order to minimize the global warming, you can just plant a new tree, look after it till it grows into a huge tree. Okay, which means simply a tree for a tree policy. It's my policy. Okay, means it simply means that I have not invented it, but I have named it. Okay, so don't let that think that I have invented it, but I have named it simply for just fun. Tree for a tree means if we are cutting a tree, okay, and if we are suppose using this wood and we are burning the wood, so what is happening? The carbon from this tree, okay, which is in this wood, okay, it is released in the form of carbon dioxide, correct? So we have introduced more carbon dioxide in the atmosphere. But over the time, when we would plant, at the same time, when we would plant a tree, okay, this tree, when it starts growing, it would use up the carbon dioxide. So we are actually trying to balance our own deeds, our own karma. Okay, means simply, I'm joking, we are actually trying to balance the amount of carbon dioxide. If we are letting up the carbon dioxide in the atmosphere, make sure that you also make something, or you also do something to consume that carbon dioxide itself. Okay, so tree for a tree policy works in that way. Fine. The carbon which is introduced in the atmosphere, okay, in the form of carbon dioxide, it can be used up by the another tree which we have planted. Correct? Fine. Moving ahead, the simplest thing which you can do at your ground level is to spread awareness about global warming, right? Because most of the people, or many of the people, don't know what is global warming, what would happen if we would let, okay, the carbon dioxide go, means enter the atmosphere at like uncontrolled level. So it would result in all these things. You can just spread awareness about all these effects, so that people would be more cautious and would think before letting carbon dioxide go into the atmosphere. Okay, so this doesn't mean that don't breathe and all those things. Okay, it's quite natural. Fine, because we need to breathe, because we need to live. But yeah, actually one interesting thing that I want to tell you, that respiration, you may think that it is letting more and more carbon dioxide in the atmosphere, but it's not the case, because it's getting balanced. How? See, actually in actual sense, this is a plant, okay, which is suppose eaten by an animal, A animal, and suppose that A animal has been eaten by a B animal. Okay, fine. Or suppose some people who are vegetarians, okay, they are like C peoples, means they are I have denoted them with the C. So this people, they directly eat vegetables, fine, or plants. So what they are doing, they are eating the plants. The carbon from the plants is entering into their body, okay, in the form of carbohydrates. They are taking up the carbon, and this carbohydrates, okay, like glucose, is burnt, right? Means glucose is reacting with the oxygen, and it's giving us energy along with the emission of carbon dioxide, which we are letting off. That is simply we are respiring. In the same way, this B category people are also respiring, okay, but these B category people have got the carbon content from A, which in turn has got the carbon content from, at the most, plant. And this plant, okay, how they have got the carbon? See, this carbon dioxide is going into the atmosphere. The atmospheric carbon dioxide is being taken up by the plant, fine. So whatever carbon dioxide we are giving up, it's actually being taken up by the plants again, and this carbon, okay, is only taken up by us again, and this is how the cycle goes on, fine. So carbon dioxide which we are giving up is being taken by the plants. So that's the thing which is getting balanced. So don't stop breathing. I'm joking, just fine. So these are the ways to reduce global warming. Now moving to the last topic of this chapter, that is, we have to study about the ozone depletion. But before that, let's have a look over ozone. Now I know you all know what is ozone. Ozone is this O3, okay, formula, and it is actually a light bluish gas, very nice, which is present in the second upper layer of the atmosphere, like second layer from the Earth's surface. So this is Earth, this is troposphere, this is stratosphere. So ozone is present here in the stratosphere, fine. So layer of ozone is present here. We call it as ozone layer, fine. So this ozone layer has a very important function. We all know it absorbs UV radiation, which are harmful for us. In what terms? If it won't absorb this UV radiations which is coming to the Earth, okay, and if this UV radiations pass on, okay, and reach the Earth's surface, we may suffer from skin cancer. Also, it is harmful for the living organisms as well. Okay, so this is a very important function of ozone, fine. And apart from that, now let's see how the ozone is formed. So ozone formation is very simple thing. See, the UV radiation itself, okay, it's playing a part. How? The UV radiation is helping the oxygen molecules, the UV radiation which is coming from the sun, it's helping the oxygen molecule to break into oxygen atoms, fine. UV radiation is helping oxygen to break into the oxygen atoms. Now this oxygen atom, what it is doing, this one oxygen atom is coming here and it is saying that I will react with an oxygen molecule to form ozone. As simple as that, correct? Okay, so this one oxygen atom reacting with oxygen molecule forming O3, O2 plus 1, O3. So this is how ozone is formed. But if you would summarize the net equation, okay, what would happen? See, here there are two oxygen atoms which are formed. So I should take it as like this much, like this. Okay, here I have just involved one oxygen. So another oxygen here, this oxygen would also do the same type of reaction. It would also react with oxygen molecule, form ozone. So if I would just add these two reactions, what would happen? Two oxygen atoms plus two oxygen molecules giving us two ozone molecules, fine. So if now this two oxygen atoms are involved in this type of reactions resulting into formation of ozone. So both the reactions have clubbed up. So I would just remove this reaction, okay, because this two oxygen atoms reaction is shown by this single reaction, fine. So removing these two reactions. Now what I would do is I would just write this reaction here itself. O2 gives O plus O, fine. And then I would make a net equation of these two equations, fine. This was the first step. This was the second step which I have erased. In that second step, we have only included one oxygen atom. So I included second oxygen atom. Then I clubbed the second step. This is the second step now, fine. So this is the second step. This is the first step. Clear? Now now if I want to know the net reaction, what I would do is I would just take out the similar terms from the opposite side of the reaction, take off the similar terms from the opposite side of the reaction, or just cancel off the similar terms or similar molecules, similar atoms, which are present in the opposite sides of the reaction, okay, which we have written in the equation, which we have written. Fine. So here see, 2 oxygen atoms, 2 oxygen atoms. Clear? So see how the way I am cancelling out, 2 oxygen atoms are there, so 2 oxygen atoms. Fine, don't cancel out this 1 oxygen molecule from here. Fine, these 2 oxygen atoms are being used up here, so that's why I have cancelled up them. Clear? So this oxygen molecule, ozone molecule, nothing to cancel out now from this side, okay, and from this side as well, nothing to cancel out. Everything is cancelled. Clear? Now let's add up the equation. So here this oxygen, okay, it is taking up this UV. Fine. So I would just add up this UV here. UV radiation. So UV plus oxygen, correct? I missed this component. So see, UV plus oxygen. Now let's again have a look over the equation in order to balance, in order to cancel out the similar atoms or similar terms. So see, UV plus oxygen not balancing means nothing to cancel out here, and 2 oxygen atoms cancelled out already. Fine. Now let's summarize the equation. Okay, club this equation. How to club this equation now? UV plus oxygen molecule, and here there are 2 oxygen molecules. So this oxygen molecule and this oxygen molecule will club. So 3 oxygen molecules would form. Fine. We can write it in this way: 1 oxygen molecule and 2 oxygen molecules, resulting into 3 oxygen molecules. Okay, so 3 oxygen molecules. Clear? So these two have now used up. Now we have written them. Okay, here. Now apart from these two, what is remaining? Plus UV only. Fine. Now on the another side of the arrow, that is on the right side of the arrow, okay, cancelled out the terms, 2 ozone molecules just. So this is the reaction of the formation of ozone. Simply 3 oxygen molecules turning into 2 ozone molecules. Okay, you can write UV plus 3O2, or you can just write UV above the arrow as well. Okay, no issues here. Understood? Got the point? Now this is the formation. Now in another, now we can see the decomposition as well. So decomposition is simply this ozone molecules, they decompose into oxygen molecule and oxygen atom. Fine. Ozone decomposing into oxygen molecule and oxygen atom. O3, it's just splitting up into oxygen, and then what is remaining? O2. So O2. Correct. But now the interesting thing here is the formation and the decomposition. Okay, I will just erase this thing. If you want to write it, you can just copy it down. Okay, the formation and the decomposition. This is the formation. Okay, this is the decomposition of the ozone. They are carried out in such a way here in the ozone layer. Okay, that the ozone amount of ozone is not reducing. Okay, now you can think, see, ozone is getting formed here, ozone is getting decomposed again. Fine. So but these two processes, the formation and the decomposition, are balanced in such a way that the ozone which is present is maintained to a constant amount. Okay, so you can see, in this way you can think that when the more ozone is added, some of the ozone is getting decomposed. Okay, so the same amount of ozone, suppose 2 ozone molecules are formed, 2 ozone molecules are then decomposed. So the ozone molecules which are present, okay, they remain constant, or the amount of ozone remains constant at normal conditions. Fine with this thing? Clear? So if the formation is taking place in such a way that 2 ozone molecules are getting formed, so 2 ozone molecules would get decomposed, so that the amount of ozone here would remain same. Okay, because 2 came, 2 left. So whatever here was present initially, that is only present finally. Clear? So the amount of ozone is kept constant. Okay, so in this way formation and decomposition of the ozone is maintained. Now apart from this, we are facing some problem. Okay, because this ozone layer which is present around the earth, which is acting as a blanket, okay, protecting us from the UV radiations, is being tampered with the chemicals. Okay, now which chemicals are causing this ozone layer to get lesser and lesser, okay, or reduce its amount? Okay, now see, the amount of ozone layer, it is getting lesser and lesser, so this is called as ozone depletion. Okay, the amount of ozone in the layer getting lesser and lesser. It's simply called as ozone depletion. Depletion means getting less. So ozone is getting less. Fine, this is called as ozone depletion. Now this decreasing amount of ozone, which is called as ozone depletion, would result into such decrease, okay, in some cases that there would be no ozone layer present at that point. Okay, and there would be formation of hole, which is called as ozone hole. Now you can see here in this way, here the ozone layer is there, but in this area, okay, the ozone became less and less and less. It depleted and it came to such point that it resulted into a hole here, which means there is no ozone there. So no ozone means here the UV rays are not getting passed, means here the UV rays are not allowed to enter. Okay, here the UV rays are not allowed to enter. Fine. Okay, I will erase this thing. Here the UV rays are not allowed to enter. See. Okay, but here the UV rays are then passed through because no ozone is there to absorb the UV rays. And if they would pass through and reach the Earth's surface, they would cause skin cancer and it would result into harm to the organisms. Fine. Now, which chemicals are responsible for such bad work or depletion of our ozone? The CFCs, which are called as freons or chlorofluorocarbons. Okay, oxides of nitrogen. Apart from that, methyl chloride, methyl bromide, or carbon tetrachloride. Okay, these molecules or these chemicals which are produced. Okay, and apart from that, the last one is greenhouse gases. Okay, so these four: CFCs, oxides of nitrogen. Okay, and then methyl chloride, methyl bromide, and carbon tetrachloride. And lastly, greenhouse gases. This deplete the ozone. Now, if ozone layer would get depleted, I have already told you, it would result into harm for the living organisms. We may be affected with the skin cancers and all those things. Clear? Okay, now let's quickly see some questions so that we can end the video. So these questions are quite like simple. If you have paid attention, you could definitely get the answers. So you could definitely give the answers, right answers, which is not a greenhouse gas. Okay, so options are carbon monoxide, methane, nitrous oxide, and carbon dioxide. So we have already studied carbon dioxide. Yes, it is absolutely a greenhouse gas. Okay, they are asking which is not a greenhouse gas. Fine. So carbon dioxide, it's not the answer. It is a greenhouse gas. Nitrous oxide, greenhouse gas. Okay. Methane, it is also a greenhouse gas. Okay. Nitrous oxide we have studied, laughing gas, right? Oxides of nitrogen, greenhouse gas. Okay. So these three are not there. Carbon dioxide, nitrous oxide, methane. Okay. So remaining is carbon monoxide. Correct? Okay. Apart from this, name the gases which are responsible for the formation of acid rain. So which gases are responsible for the formation of acid rain? Okay, oxides of sulfur and oxides of nitrogen. Correct? Now which oxides of sulfur? The sulfur dioxide also reacts with rainwater, but it needs oxygen also to form sulfuric acid. So it is also responsible. Correct? Apart from this, sulfur trioxide, simply it reacts with the rainwater and forms sulfuric acid. So these two oxides of sulfur are responsible for the formation of acid rain because they are resulting into the formation of sulfuric acid, which is in turn mixing with the rainwater and forming acid rain. Okay, so they are indirectly, okay, they are forming sulfuric acid. Sulfuric acid plus rainwater is getting converted into acid rain. Correct? So these are responsible, right? So name the gases which are responsible for the acid rain. These two. Okay, apart from this, oxides of nitrogen, in that only nitrogen dioxide we have seen, okay, here, which reacts with the rainwater and it forms nitric acid. Correct? So these three would be the answer. Clear? So students, with this we have reached the end of this video. So I hope you would have enjoyed learning with me. You would have understood the concepts which we have learned in this video, but please do let me know this thing in the comment section, right? And as you all know, Learnohub matlab free है पर best है. So see you in the next class, that is your class 10th first chapter. Okay, till then, now all the best for your exams. I hope you would have followed this so you can use the concepts which you have learned, okay, throughout these videos and use them efficiently, use them not only for writing the exams but also keep them in the brains because you would need them definitely in your class 10th as well as if you would pursue higher studies in chemistry that time also, because these are the basics, right? So then keep studying. Goodbye and have a great day.